Hello and welcome to another episode of AWS Cloud Bytes. This is our deep dive into building a robust and scalable content integration and processing pipeline using Amazon Web Services. In today's interconnected world, handling vast amount of user-generated content, media, or data stream is a common challenge. How do you ensure your system can reliably accept content, process it efficiently, and then trigger multiple independent actions, all while remaining highly available and cost effective? That's exactly what we will explore with this architecture diagram, focusing on the powerful Fanout pattern to distribute tasks. Imagine users uploading videos, images, or documents. We need to store them, create thumbnails, transcode videos, analyze text, and gather metrics, often simultaneously, without any step blocking the others. This demands an asynchronous, event-driven, and loosely coupled design. Our solution leverages AWS serverless services, embracing the principle of elasticity, cost efficiency, and minimal operational overhead. At its heart is the fan-out pattern, where a single event can trigger multiple independent consumers. Let's start at the beginning. The user uploads a file. It could be an image, a document, a video, directly to an S3 bucket. Amazon S3 bucket is a highly durable, scalable, and cost-effective object storage service, perfect for raw content. An S3 bucket can be configured to listen to a file upload event. This triggers our ingestion processor over here, which is an AWS Lambda function. This Lambda's job is simple: validate the upload, store the initial metadata if needed, and then most importantly, publish the content ingestion event. So this is raising an event that is going to an SNS topic. So what are the key points from the file upload till SNS? Firstly, there is an S3 event notification. The Lambda's role as a event handler and a lightweight processing and raising an event. Now here is where the fanout truly comes into play. Our event that was raised, the content ingestion event, it's published to this SNS topic. Now SNS topic, or simple notification service, acts as a message broker that can send the same message to multiple subscribers simultaneously. Instead of one service knowing all about the other service, our ingestion processor just talks to an SNS. So it doesn't need to know anything about the thumbnail generator, the transcoder, the text analyzer. Ingestion processor just needs to publish it. And what SNS is doing is it's broadcasting that information. This completely decouples our system. Any new service that needs to be added to react to the content upload can simply subscribe to this SNS topic without altering any upstream code. The key points to remember over here are: it's decoupled, it's asynchronous communication, and one-to-many messaging. Once the file has been uploaded and a topic has received the event, in this case, this topic has received an event. For images, the SNS message is delivered to image processing queue. SQS is simple queue service. It provides a reliable buffer for messaging, ensuring that the downstream processors can pull message at their own pace. In this case, the processor of this queue is thumbnail generator, which means any message that has been uploaded over here, it's in the message queue. The message in the message queue, but the file is still in the S3 bucket. So there is a path to the file in the message. Now, the thumbnail generator can work on its own pace and generate the thumbnail by pulling this file from S3 and generating a thumbnail and dropping it to a different location altogether. So image processor Lambda is doing all that activity. Key points to remember over here are SQS is for reliability and decoupling, and you're chaining Lambda functions. Similarly, if there is a requirement for videos, if video is uploaded or required, then SQS processor queue over here, which is named as video processor queue, will receive that event. The transcoder Lambda, which could also involve AWS Elemental Media Convert for heavy lifting, but simplified here for illustration, processes the video, converting it to various formats and resolutions. These transcoded videos can then be saved to its own S3 bucket. It can be a separate bucket, it can be a folder in the same bucket. The key point to remember over here are that if there is a video requirement, we are encapsulating the video processing complexity in this transcoder, which can actually call other services to perform those actions. And it has its own path to deliver the output. If there is a third requirement where for the given file, you need to have text analyzed, then in that case, there can be a direct integration without having a queue in place. So you can see a text analyzer Lambda is over here. It can use Amazon services like Comprehend to extract entities, sentiments, or keyword from other content, and can then further publish information with an event like text analyze event to another SNS topic. Let's continue to the path of this SNS topic. So once the text has been analyzed by text analyzer Lambda and published to an SNS topic, it demonstrates how events can flow through multiple stages. This event fans out again. So this is the first fan out, and this is the second fan out that happened in the same path. So it triggers another queue, basically, is a subscriber. So this queue is also subscriber to this topic. Search index queue will receive the information or the message that was published by text analyzer, and then that information can be updated in a search index like an open search or elasticsearch. So this processor over here, index content Lambda, can do that for you. Simultaneously, the text analyze event can also be processed by Amazon Kinesis. Kinesis is excellent for real-time data streaming, allowing us to capture and process streams of events like metadata changes, user interactions. Now from Kinesis, we have this store metric that can use that information, aggregate the analytics for dashboards and reporting in a near real-time fashion. The third one can be ML feature extractor. Now this Lambda can pull the data based on the text analyzed in this event, whatever data is. It can pull that data and send it for machine learning models. These models can then train using the dataset that has been updated. So you can see in this section over here, you can perform multi-stage eventing. You had an event and that triggered another processing that triggered further event. You can do real-time streaming. You can do ML integration. You can perform monitoring and analytics. Just to summarize, what are the immense benefits of this architecture? Scalability. Each component scales independently based on demand. Resilience. SQS queues and asynchronous processing protect against failures. Cost effectiveness. You only pay for what you use with serverless services. Flexibility. Easy to add new processing steps or modify existing one without impacting others. Maintainability. You have smaller decoupled services that are easier to develop, test, and deploy. This content ingestion and processing pipeline, built with AWS's robust serverless ecosystem and the powerful Fanout pattern, provides a flexible, scalable, and highly available solution for handling diverse content. This is a fantastic example of how we should design modern event-driven applications. Thank you for watching. If you find this helpful, please like, share, subscribe for even more architecture deep dives.